Uh, Hi everyone. I think it's 5. We can start now. So just let me share my screen. Okay. So welcome to week 3 of this live session for welcome to week 3 for the live session on NGS data analysis and applications. So this week we'll cover Linux commands and like what you can do, how you can modify your files, how you can move your files from here to there, and how you can do various stuff, things with your like data using just Linux commands. So we'll start from the very basics and kind of only cover those kind of commands that is useful for the bioinformatician. So Linux is a very big ecosystem, right? Like there's a lot of stuff in Linux and Unix. So we'll not cover all of them. We'll cover only the parts that we require actually, and after that, I'll walk you through how to use those commands and everything. And towards the end of the session, we'll actually try to use bbduck as Sir also used, and try to like do some pre-processing on some FASTQ files that Sir has only provided. So first of all, let me give you the link to the FASTQ files. You can look through it. So we'll only work with the FASTQ files in this folder currently. In the next few sessions, we'll use the rest of the files as well, like where you can take a look into how to process BAM files and other type of files as well. Okay, okay. So let's get started. So initially, for Linux, you need to know, uh, first thing you need to know is how to navigate through Linux. So how do you change your directory? How do you check the contents of your directory? How do you check your working directory, and how to basically navigate through your basically operating system. So these are the first few commands that we'll be looking at. So before that, let me pull up my terminal. The people who have Windows here, I hope you are using a WSL. This is the uh, thing. If you are using Windows, you can just simply download WSL using open your command prompt, uh, right click on it, and click on open as administrator, and after the command prompt opens, you type this WSL space hyphen hyphen install. It install WSL for you. Now next, when you try to open WSL, open with administrative privileges as well, so that you can write files, you can delete files, those kind of stuff. So this is just like what is it, a walkthrough of how to use Linux system. So we'll do some like we create some files, we'll edit those files, we'll remove those files. So those kind of permissions are required for your actually those kind of permissions are required from your system to do this stuff. So open as administrator always. Okay, so if you are using WSL, please uh, download from this link, and let's get started. So if you are using Mac, so mine is a Mac, so for Mac you do not need WSL. You can directly use your terminal. So I just go and search terminal here, and it opens up. Okay, so this is as I said, is a Mac. This is not a Linux system. So what I'll do is I'll connect this system to my lab system, which is a Linux based system, and we'll like do the tutorial everything through my lab system, so because this is not a Linux based system. So first, to connect to a different IP or a different machine. So what will happen is when you are using like when you are working on genomics data and other kinds of data as well, like NGS data, different kinds of data. So usually we use uh, lab systems, or if we have an HPC in our department or in our institute, we use those. So for my case, I have an HPC in my department at CBRISC. I use that. I also use my lab system, which I'm going to connect and show you all. So the process of connecting from your terminal to the system of your choice, be it your lab system, be it your HPC. So the way to do it is use a command called SSH. The format is SSH, and then you specify your username. This is my username for my computer. So it'll change on. Sorry. Yeah, this is your username will depend on the account name of your profile in the system, in the system that you're trying to connect. So in my system that I'm trying to connect to, my username is this, and then you give an at the rate, and then you have to type the IP address. Let me check my IP. Yeah, so this is my IP address. Uh, So this is, I'm just showing you how to use SSH and everything. You will be doing this tutorial in your own system, so you do not need to connect to any other system. I'm just showing you how to do that if you require. So you give SSH and username at the rate the IP address, and you click enter, and it asks for my password. So let me enter my password. Yeah. So see, it is connected to the system, to my lab system. Now I can do a simple ls to check what are the different uh, files in my lab system. Sorry. Yeah, I can do a simple ls to check my what are the different files in my file system. If you want to sort them by say time or different sizes. So for example, for time, you use hyphen LTR. So, okay. Yeah. To sort it by time, you use hyphen LTR. So these are all the files that are present in the system that I'm connected to, and these are their permissions and everything. And then what I want to do is I want to change. I want to go to this downloads folder. So these are all these purple ones that you see. I'll just increase the font that you can see better. Yeah. Ah, yeah, these purple ones that you see here are basically the folder names. So I want to go to my say downloads folder. So I do a CD and then I type downloads and comes like this. And now I've changed my directory from my home directory to the downloads directory. Now let's go through the commands now. So if you want to make a directory here, if you want to make a directory here, you use a command called mkdir. So it's make directory. It's a simple command, and the format is mkdir space the name of the directory. So here, now I'm currently in my downloads folder. Now let me check my downloads folder. There's a lot of stuff in my downloads folder. Ignore that. Now I want to make a directory in my downloads folder. So I do a mkdir say Unix tutorial. mkdir space the name of the directory. So the directory will be created in the space you're currently in. So I do that and it has done. Now let me check if this directory has been found. I do a ls. I often use LTR because I want to sort them by time. You can just use ls or LTRH. There are different forms of ls. So ls is basically the list command which gives you the list of files that are present in that particular directory. If you want to sort them by different means, you can use different types of this hyphen LTR, LTRH, or LR, whatever you want to sort it by. So I want to sort it by time from uh, like at the bottom will be the newer ones and at the top will be the older ones. So I do a LSLTR. Now see the Unix tutorial folder has been created. Now if you want to go to the Unix tutorial folder, you do a CD from here and then you type Unix tutorial, hit enter. Now let me check what are the files present here. ls, there is nothing, no output, that means no file is present. Now say for example, now on the left you see this is giving you the directory at which you are currently present in. Now what happens is in maximum of the cases this directory is too long. So what they do is they in the Linux system you'll see that has been shortened to a little bit, so you cannot actually see just from this line sorry just from this line or this line, whatever be it, you cannot see where you are but in the directory, so in which folder you are uh, com- compared to your home folder where you are currently in your directory, you wouldn't know that. So another command that comes into quite handy is pwd. So this gives you your current directory. So see, this is my current directory. So I am in downloads. This is my home directory. And after that, I'm in downloads. And this is the folder that I just made. And I'm inside that folder again. And this folder is empty. So ls does not have any output. Now we have covered all these four commands. So mainly what you'll use these four commands for are mainly for creating directories using make mkdir, for printing where you are in the current directory. pwd is the command to do that, and cd is basically your change directory. Now cd has a few small details, so I'll show you. Now say for example I am in this directory where uh, I was in my home, then I moved to downloads, then I moved to this Unix tutorial directory. Now what I want to do, I want to go back one directory. I want to go to the downloads directory back. Now I do not want to get this whole thing, cd, home, name, then downloads again. What I want to do is just I want to go back one directory. So for that the command is cd space, you do a dot dot and then you enter. Now you are in your downloads directory. You can check using pwd. Now see, I have come to my downloads directory. I've come out of the Unix tutorial directory. Now another thing for CD is, let me go back to Unix tutorial directory. Now another thing for CD is, say for example at any point of the time you have navigated through some directory, you have gone inside looking for files and everything, you've done your work. Now you want to come back to the home area of your system. An easy and a shortcut way to do is just cd space and then enter. Now I am back to my home directory. I've come out of Unix tutorial. I've come out of downloads. I'm back at my home directory. So CD has some certain extra these things where you can use a dot dot is basically going back one directory. CD space enter is basically going to your home directory. And say for example, I want to let me go back again. Downloads Unix tutorial. Yeah. Now, what I want to do is basically I want to go back to the home directory, but not go back to the home directory. In this case, it will be the home directory. What I want to do is exactly go out of Unix tutorial and also go out of downloads, meaning two steps back, not one step, but two steps back. So this was one step back, cd dot dot. Now I want to go two steps back. So what I do is cd dot dot, I put a slash, then I put another dot dot, then I put a slash again. I do enter. I'm back at my home directory because there were two directories after that. So basically, if I want to move out once of my directory, I do a cd dot dot like this. Remember, there's a space between cd and dot dot. Just do not miss this because otherwise it won't work. So if I want to come back, come out twice of the directory, so out of Unix tutorial, out of downloads as well, I do a cd space dot dot slash, then I add another dot dot slash, which brings me back to two directories back. So these are all the things that will maybe like required while trying to do different things, but these are um, basic uh, commands for making directories, for checking where you are in your system, for basically uh, coming back or going inside a particular directory, basically navigating through your system. So these four commands are something that you'll use very frequently. So this is another command, cd space. Let me show you. Let me go back to the downloads and next tutorial. Now cd space this symbol. If you do, it will bring back to your home again. So if you see on the left, how the directory is given, this is the name of my system, then there's a colon, and after that this is what signifies the home directory, this curly thing. I'm not sure what you call it, but basically this thing, it's on the for me it's on just below the escape button, but it's the curly hyphen, you can say. So when you use this, it will come back to your home directory. So this is another way to go back to your home directory. And if you see here as well, this is how they show you your home directory. So yeah, so these were the commands that you use to basically navigate through your directory. Make, make directory, print your current working directory, change your directory, and list the contents of your directory. So these are the major things that you require. Other than this, there are other certain commands, but these are the major ones. Like you should not require anything more than this, because this will cover mostly everything. Now let's move to another set of commands. So these are basically file creation and editing commands. So ls, as I already showed you, excuse me, uh, ls, as I already showed you, lists the contents of your directory. But something like this, so if you say, for example, let's go back to my terminal, let's go to my downloads folder. Now I do a ls basically. So there are a lot of files. See, so there are a lot of files. So, but I want to find a particular file, and I do not want to like kind of scan through each and every file and check where my file is. So if I know the name of my file, say for example, this is my file, and I want to check if this file is in my directory. So what I do is I do a ls space that name of the file, I do a copy paste, and I enter, and see, it's here. If it is printing the name of the file, that means it's in the same directory. So ls also helps you find files, not only like list your files, but also find specific files that are present in your system. If you have the name of the file, you can do a ls space the name of the file. It will show you if the file is present in that particular directory or not. Okay, so yeah, that was for ls. Now let's try to try some file editing commands as well. So let's try nano. So okay, so Nano, what helps does it? It's basically helps you create or edit a file. So I'll show you the difference between Nano and Vim in like right now only. But these are two different commands, but like you can use both of them. Slightly different in terms of implementation, but these are quite similar. So let's try with Nano first. So let's say I want to. Let's go back to my Unix tutorial directory. Now let's say I want to make a file in this directory with a certain name of my file. Say the name of my file is something, and I want to make a file, create a file in this directory. How do I do that? There comes the nano command. So you do a nano space the name of the file. Say for example, this file is, say I name my file something like this, my first file.txt. So nano space the name of my file. This will create the file. So this is basically the file that is being created, and this is basically the screen in which you can uh, basically write your files and like edit your files and everything. And this is just a blank screen right now. I'll copy some text into it. Let's take a random text. So this is a random paper that is open here. I'm just copying whatever I find first, and paste it here. Sorry. Let me do it again. No, I think it's not copying. Uh, so I just copied a particular part of the file, part of the text here, and I can navigate through this text. See, the whole line has been copied from here, and I can also make edits. So I can remove this word. So, for example, I can add another word here like this. It's it's quite easy to use. Now, uh, this is I just want to show you how it does it. So, yeah. So in one line, the whole text has been copied. Now, what I want to do is I want to save this file. So I do a control X. I do a control X and it says save modified but buffer. I can use a yes or a no or a cancel. If I want to keep modifying my file, I use a cancel. That is control C. Uh, and if I want to save the file, I just put a Y and it's saved. Y and enter. Now this I have created my file. Now let me check if the file is present in my directory. Now yeah, see, I do an ls and this is the only file that is present in my directory. Now the other command comes. So this was nano. So nano, you can create a file and edit the file. But what I find more useful is basically Vim. I'm more comfortable with Vim than Nano. Many people use Nano, but Vim is something that is very easy to use. I'll show you. Say, for example, this is your file that you have created. Now you want to see the file. So there are two, like Vim has two basically sub commands. So one is Vim itself. So Vim is something that is used when you are creating a file, but it can also help you see the file as well. So say for example, I want to see the file. I do a Vim space the file name. See, I can see the file here. I can read the file here. The whole file is all the text is here. Now, if I want to come out of this without making any changes, without doing anything, I want to keep the file as it was. I just saw the file. Now I want to come out of the file. What I do is press escape. So escape meaning like now you're not editing or doing anything with the file. After escape, you put a colon. So if you notice on the left corner here, the colon has come. After a colon, there are a few options. First is Q. If you do a simple small Q, everything is in small, just remember. If you do a small Q, it will come back without saving anything, without making any changes, without doing anything. Now, let's open the file again. Sorry. Okay, now want to make certain changes. I want to like edit this file. I want to remove certain words, insert certain words, and do whatever. Now, for that, the command, the way is to use the I key in your keyboard. If you press I, if you see on the bottom left, here your insert has come. It means like now you can edit your file using your keyboard. Now, say for example, I want to remove this particular Python CMD Python. I do a backspace and it gets removed. See? Now it's gets. I can edit. Now I can write something as well and do whatever you want to do with it. Now, when you're still in this insert mode, so after you have done editing the file and doing whatever you want to do with the file, now we want to come out of the file. There are two options. So first you have to go out of this insert option. So how to remove the insert option? You press escape again. Once you press escape, the insert option is gone. Now it's the same thing. You put a colon comes. Now, as I showed the last time, using colon Q only like does not change anything in the file. So it was just viewing and you just quit the file. It does not do any kind of changes or does not do any kind of editing. Now, if I do the Q colon Q thing, see, error will come. Say no write since last change, add this is the exclamation mark to override. So basically, if you do something like this, colon exclamation mark q, what it'll do is it'll force change the things back to whatever it was, and it'll not consider the edits that you have already done here. So it'll go back to its original state. But what I want to do is I want to change. I have changed the file. I want to save the changes. So for that, the command is wq things, write and quit. So this is the command which you see, colon wq. Yeah, colon wq. So what it does is basically it will save the changes that you have made in the file. So if I do a colon wq and hit enter, it closes the file and it has saved the changes. Now I want to check if it has saved the changes or not. I do the same vim, my the vim space the name of the file. See, we have there it has made the changes. Now the changes has been saved. And now like this is the file that we were doing changes on. Now I have seen that it has made the changes. Now I do not want to make any more changes. I have just seen it and I want to go back. No changes made. Then you do a colon and a q, it comes back. One thing to say before I move on to the next commands. So vim is a very useful command to in Linux. So but remember everything when you are writing something, always use I. So whenever you press I, this insert option comes on, and whenever you press escape, the options goes off. So another option in place of I is R. So with R you can replace as well. But using I is a better option because it just help, like it'll allow you to edit things in a very much more simpler way. You do not need to replace something with something. You just want to remove and rewrite. So this is a better way to use it. So after you have done, you just want to quit. There are no changes you have done in this one. You have already saved the changes in the previous time. So you just want to quit this file. Do a colon and a q, and you are. So I have written. See, I have inserted this r. So that's why it's telling me there has been changes since the last save. So I need to save it again. Or if I want to go back to the last save thing, I do a exclamation q and I go back. So it asks me, sorry, yep, yeah. So yeah, this is how you go back. So vim and vi, these two commands. So one is vim and another is just vi without the n. So what happens is when during creation of a file, generally we use vim, and while editing a file or like opening in an editor, we use vi. But you can use vim there as well. But while creation of the file, you cannot use vi. So vi, say for example, I want to make another file, say with the name of my first file 2.txt. If I do a vi like this, it'll open up a new file because there is no file available. So these are things that you can do interchangeably. But if I do a, just a quit, it'll see the file is gone. This file is not saved, right? So while creating a file, the uh, uh, better to use vim, and while opening the file in an editor to edit things, you would want to use vi, but you can use them interchangeably. It doesn't actually matter that much. So yep. So let's move on to the next set of commands. Okay, so uh, after viewing and so after editing and making the file, you want to just say, for example, you just want to view it not in an editor, just in your terminal. You want to view the whole, either the whole file or a part of the file. Say, for example, you just want to check the head of the file, like the first few lines of the file. Then also, if you want to check the tail of the file, just the last few lines of the file. And more or less these are like also commands where you can see like part of the files, but these are one thing to remember: all these commands, cat, head, tail, more, less, or seek, these do not, these are not like file editing options, right? You, what you do is basically you either you view a part of the file, or you want to check specific parts of the file, then you use these commands. You do not use these commands to edit files or even make files. Okay, so this few commands, cat, head, tail, more, less, see. So basically, you can remember it like this: a cat has a tail and a head and a tail, more or less. So this is something you can remember by. But basically, just remember the important thing that you do not like these are not file editors. So this will only give you a view of the file, nothing less, nothing more, nothing less. So depending on which part of the file you want to see, you can use these different types of commands. Now let's go back. Let's open this file. Now let's make this file a little bit bigger. Okay. I do a I. Now see, insert option has come on the left below. Now I want to write something in the file. 2, 3, 14, 15, 16. Okay, so now I have edited the file. Now what I want to do is to save the file. So I press escape, colon, WQ, it saves the file. I want to check if the file has been saved or not. I see the file. Now this file has been saved. On the left below also, just keep this in mind. Uh, it shows you the number of lines in the file and also the number of characters in the file as well. So this gives you something that is like basically useful in certain cases. So for example, you want to check how many rows are there in the file, it will already give you the number of lines in the file. You do not need to do anything to find out. You can directly open the VI editor and you can and check the number of lines in the file. Let me go back now. Uh, now let's try the cat command. So first the cat, then head, tail, more, less, and see. So sorry. Let's first try the cat command. Cat, same file. Now see, what's the difference between cat and VI? I hope you can understand from this thing. Cat and your file name gives you the whole file, but it does not give you an option to edit or do anything with the file. It just shows you that this is the file. That's all it'll do. It will not give you an option to edit the file. So the major difference between cat and VI is basically cat will show you the file, it will not allow you to edit. VI will show you the file and also it will allow you to edit. Now, when to use cat, when to use VI? So, cat is basically, say for example, you have a very big file. It's a very big file. Say you have around 5 million or 10 million lines, and it's not very unusual to have those big files because, say for example, you're dealing with the number of SNPs of an individual. So there'll be millions of SNPs in an individual, or say for example, you're dealing with some sort of GWAS data. So there will be millions of SNPs in this GWAS data. So you cannot see them at one screen. So basically, uh, what will happen is if you do a VI on those files, so since VI is an editor, it takes much more time to open the file because it's an editor. After opening the file, it will allow you to edit the file. But since cat only shows you the file, so in those cases, if you just want to check the contents of the file or just the heading of the file, you do not use VI. You use commands like cat or with the next command will show you head. So head, it it does not show you the whole of the file. It will see. So my file is this sorry this paragraph along with like 1 2 3 4 5 6 7 8 till 20. But if you do a head, it only shows you till 9. It does not shows you below what is that. So head only shows you the first few lines of the file, and the opposite of it is basically tail. Tail space your file name. It will show you the last few lines of the file. Okay, so if you just want to check the header of the file, what are the, say for example, you have a tab delimited file with basically different headers, and you want to check what are the headers of the file. So that then you use something like head. If you want to check what is at the lower end of the file, what is the last few rows looking like, you use the command tail. So these are like opposite commands, head and tail. But also to remember one thing, these commands do not allow you to edit the file in any way. It just shows you what is in the file. You cannot edit. Okay. Okay. Cat tail head. Now let's try more. It also will show you the file. The importance of mode comes also when your file is big. So what mode does is it allows you to step through the file one screen length at a time. So you can just scroll the screen like this if it's a very big file. So it cannot be included in one screen, and you have to scroll through the file. It's not very easy to scroll through because in Linux you are not allowed to use what to say mouse mouse gestures. So it's very hard to like come. Say for example, you have 10,000 lines in the file. You have opened the file and you are in the first line. Now you have to go all the way down to 10,000, just pressing the downward arrow button and try to see what is there in the file. But more gives you an option to, for that to make it easier basically. So what more will do, since this is not a big enough file, it's not much different from a cat. But what more will do is if it's a very big file, it will allow you to scroll through the file one page at a time. So if you can check the contents of the file one page at a time, and you can scroll it through very easily because uh, it allows you to do so, which basically cat does not allow. So this thing is it's similar to cat, but it allows you to scroll. And again, this thing it does not allow you to edit the file as in vim or the other commands. It does not allow you to edit the file. Okay, so yeah. So less is also similar. It's basically if you want to see a part of a file like this, it gives you this, right? Less also just opens up the file in a page, but the point is this also does not allow you to edit the file. So more, less, head, tail, these are mostly similar types of commands. It's just that when and at what point you're using these commands will depend on what kind of data you are looking to go through. If it's a very big data, you do a less or a more for just to basically scroll through the whole file. But if you want to edit the file, you use a vim or something of those order, vim or nano. So if you want to edit, it's vim, nano, and vi is another part of vim only. If you just want to check out the file, just check the contents of the file, cat, head, tail, more, and less. These are the uh, options to just to check out the file, not edit. So for big files, you would want to check out the file rather than opening an editor. So that is where these things come in handy. Okay. Okay. So the last command for viewing file contents is basically seek. It's not exactly viewing file contents. What it does is basically it gives you a sequence of numbers. Say for example, let's take this seek 1, 1, and 10. Let's try this seq 1 space 1 space 10. So what it's giving you, what it'll give you is basically one is it'll start from 1. The difference between 1 and its next number will be 1. So this is given by 1 in the middle. And what is the last number that should be printed? That is given by the last number here. So if you do a seek 1, 1, 10, it will do something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if you want to do, say for example, 20 with 2, see 1, 3, 5, 7, 9, 11, 13, 14, 17, and 19. So it, the leftmost and the rightmost numbers define the range at which you want the series in, and in the middle is basically the difference between the two, between second and the first, third and the second, fourth and the third, and so on, like difference between the numbers or consecutive numbers. So this is what C gives you. Okay, so if you say, for example, you want to write this in a file, how will you write it? So you do something like this. What you do is you direct the output of this command. This is the output of this command will be generated, and you're directing is this using this greater than sign into another file. Say, for example, test file dot txt. Now let me check text file dot txt. Let me open it in vi. See, it has been saved in this file. Right. So also if you check your directory, now you have, instead of one file, we had only one file. Now we have two files. Right. So this greater than arrow thing is basically uh, directing the output of this particular command to this file. So if you are interested in like doing something like this, so for example, you have a command and you want the output of the command be written to a file directly, you can use syntax like this. So it directly writes it into the file, so it does not show you on the screen like this. So for example, this one showed you in the screen, but this, since I have directed the output to another file, it saves it in the other file. Okay. Now these are different commands for renaming, copying, and deleting files and directories as well. Just a second. Okay, so let's start with touch. So I want to make another file, touch test file 2.txt. Now see, this command has ended. Now like it doesn't open up the editor as in for a vi or a vim. It just creates the file. Now let me check the file. It has been created. Yes, it has been created in my directory. Now touch is another command that basically helps you create the files uh, depending on your depending on how you're using. So what it is used for is basically to create many files quickly. So you just do a touch file 1, touch file 2, touch file 3, and it creates empty files. Remember, these are all empty files. These are not, the files do not have anything inside them. See, this is giving you the what to say, the uh, size of the file. So it's 0, and if you, even if you open the file using a vi or something, vi test file 2, sorry, yeah, if you open this, this is an empty file, right? So it's 0 lines and 0 characters. So touch quickly creates many empty files. So uh, like you can use multiple, like what you want to do is basically you want to create multiple files at once, then after that you want to edit them one by one. That is when you use touch. So touch will create these multiple files, but all of them will be empty. Just to remember that. Okay, so this is touch. So now moving on, mkdir I already showed you. I'll show you another time. So mkdir actually makes the directory. Do mkdir test like this, and it makes a directory. Now check if the directory has been formed. Yes, it has been formed. Now mkdir will make the directory. Now if you want to remove the directory, say for example, it's a directory that you have. Just a second. Yeah, it's a directory you have created by mistake or something, and you want to delete it, or there is something inside the directory and you want to delete it. So there are two options. Why? One is finding if the directory is empty or not. If the directory is empty, you can use directly this rmdir, sorry, rmdir uh, command. So if I do a rmdir test like this, rmdir space the name of the directory. Now I check if the directory is present in my system. No, it's not. Now another way to do is basically, say for example, sorry, I thought somebody was coming. Okay. Say for example, you make the directory again. Now it's there. The test directory is there. Now let's make a file inside that. cd test. Now this directory is currently empty, so there's no output for ls. So we want to make a file here. Say for example, this one only that we were doing, seek thing. Let's make a file inside this directory. Okay, so it'll contain, like, start from 1, then 1 3 5 7 9 till 19 it will go on, and it will be saved in this test file.txt. Now let me check. Yes, the test file is there. This inside this test directory. Okay, now let me come out of the test directory. Yeah, you can speak. Hi, you raised your hand. Polum.
It's okay, sir. It's okay.
Okay. Okay, so I've come out of the directory. So it's now, this is the directory that is that I made, and inside it there is the file that is present inside this. Now, if I want to remove the directory using this command rmdir, right? So let me type rmdir test. See, it gives me a output saying rmdir failed to remove test because directory is not empty. So rmdir directly using rmdir will only remove those directories which are empty. Your if your directory is not empty, it will not remove. It will give you a command, like it will give you an output like this saying the directory is not empty. Now, if you want to remove the directory, even if it is not empty, still you want to remove it. Say rmdir, you add a command extra which is -r, and then you write the name of the directory. Now, if I, oh, sorry, it's this rm space -r, and you give the name of the directory, it will remove the directory. Now, let me check if the directory is there. See, the test directory here that was there, it's gone. So, if you want to remove an empty directory, rmdir does it for you. If not, you do a rm-r. So, this rm command as well, it's here as well. So rm removes files as well. So if you want to remove files, not directories, say for example I want to remove this test file 2.txt. This is an empty file, so let me write something in this file. uh, I do a I insert. Now let's write this. Sorry. Now I've written this file. Now I want to save this file. I do a escape, then I do colon and double click, saves the file. So let me check if the file is there. Yeah, see, it was previously 0. Now it's like around 52 bytes. It's taking place. So basically, the file is not empty. Now, if I want to remove this file, say for example, this file I want to remove, but this is not an empty file. I can do a simply rm, and I do give the name of the file. It removes the file directly. See, this file is not here. Okay, so rm will help you remove the files. rmdir will remove your empty directories, but if your directory is full and still you want to remove it, this is the method rm space -r and then the name of the directory. Okay, okay, uh, okay. So two more commands left here. So let's make another file because we want to. Let's make a directory again. Let's make the same directory test, and let me check. Now, yeah, this test directory has been created using mkdir. Now, what I want to do is I want to copy this file, this test file.txt, into this directory. Right. So the command is cp for copy and mv for move. I'll come to mv as well. So cp copies a file from one place to another. What is the command? Cp space the name of the file with the location. So since I'm within the directory, so it's the same location. Just the name of the file. Cp name of the file. I do a copy paste here. Now I want to move it to test. Now, how do I move it to test? I do a dot slash. So it's what it is telling me is the directory I'm moving into, it's basically within the same directory I'm currently in. So I'm currently in this directory, downloads unit tutorial. Now, inside this directory, I'm already there. I want to move a file from this directory to another directory which is inside the same directory, right? It's the test directory is already inside the same tutorial directory. So I want to move it there. So I do cp space name of the file or the location. If say for example, I am in this Unix tutorial directory, I want to copy something from downloads. So what I need to do is I need to give the full path of the file. So that will be like down, like with the whole thing. If you remember this thing, so I'll just do it here only. PWD. So basically, I have to give the file path as home name downloads slash the name of the file, the whole path of the file, not just the file name of the file. Since I'm already inside the directory in which the file is present currently, I do not need to give the whole path, just the name will do enough. Now if I do a cp space, say for example I want to copy this file, that's the name of the file that is need to be copied to another space. So the command is basically cp name of the file you want to copy, another space to the place you want to copy. So this time I want to copy it to this test directory. So I do a dot slash test. Okay, so this is the whole command. Cp is telling it to copy. This is the name of the file and this is the destination of the file. Do I enter? Now I check inside test. See, the file has been created. Okay, so do not like ignore the timestamps because I think my lab computer is a little bit iffy in terms of the time. So ignore the timestamp, but yeah, like in yours it will be the same time that you're doing it. But anyway, yeah, this is the file that I have already copied here. Now let me check the file. It's the same file that was there. I have copied it here. Cool. Now, if I move back to the Unix tutorial folder, I just want to move back one folder. So I do a cd space dot dot. It goes back to the old folder. Now I want to check. See, this file is still here. And inside the test, it's the same file there. So the file has been copied. It's not been moved. Now I want to move the file. Like, do not keep a copy of the file in this directory. Move the file entirely to another directory. So let me go here first and delete the file. This is the file. How do I delete it? I do a rm space name of the file, it's deleted. See, it's empty. Now this test directory is empty. Now I want to go back to the Unix tutorial directory. I do a cd space dot dot. Now I do ls. Okay. Now I want to move this file, not copy this file to another directory. Move it completely. I want to move it completely. So the command for that is mv for move. Mv space the name of the file. This is the name of the file. Then space, again, it's the same as CP. CP and MV have similar syntaxes. So CP or MV, space, name of the file, and then the location of the file you want to move it to. So this time I want to move it to test. So let me check here. The file is gone. See, this was the file that I was moving. It's gone from this directory. Now let me check the test directory. See, the file is here. So two things, copy and move. So if you want to copy a file, you use cp. If you want to move a file, you use mv. Right. Okay. Moving on. So now these are things that are a little bit like what to say. These are things that you'll require when you are uh, basically trying to do something. Basically, like for example, you want to check the number of words in a particular file, you want to sort the file, or you want to do something else with the file. So basically, editing the file using Linux commands, not like going into the file editor and editing it manually. You are using Linux commands to directly edit the file from your terminal, not like using a file editor. Okay, just a second. Okay, so first is the word count. Word count will tell you the number of words in a file. So this is my directory. This is the file. I want to check the number of words in a file. So I do a WC. WC stands for word count, and it's WC space the name of the file. It gives me the number of words in a file. Right? So this is 25, which is the word count in a file. If you want to know the length of the file, say for example, so number of lines in a file, you do a WC hyphen L, give you 10. So there are 10 lines in the file, and the total number of word count there is 25. So if you want to check the number of lines in a file, this is the way to do it. WC hyphen L space the name of the file. Now, these are like word count mm, commands. Now, if you want to say sort a file, so let me make a file which is unsorted first. So first, let me check this file. Okay, so I'll add some random numbers on top. 78, 43, 195, 95, 90, 32, 4. So see, this is an unsorted file like this, so a random set of numbers here. Now I want to, I will save it because it is in VI. I will save it with hyphen WQ. The file is saved. Now I want to basically sort the file using sort. So the thing is, if you do sort and just the file, it will give you an output like this. So sort, it sorts the file and it gives you an output. So it how it is sorting. If you see it, it's sorting it as a string, not an integer. Why? Because so see on the left you have all the ones, then comes the two, then comes the three, four, five, the first digit of those letters, 7 and 9. On the right, then again comes 1, then 3, 5, 7. So it is sorting as a string, uh, not a number. So it's not assuming that like 195 is a bigger number. It's a smaller number than say 19. It's not uh, it says 25. It's not sorting like that. It's sorting as a string. So if you write words, it will sort as in a lexicographical order, A, B, C, D, like that. It will sort like that. Now, if you want to save this sorted file, like you sorted the file and you want to save this file. So as I said, you put the command like this and then do a greater than arrow, and then you save it in another file like this. Test file 1.txt. Now see, it doesn't give you the output. The output is redirected into a new file. If I do an ls test file.txt and if I view this file, see, the sorted file has been saved here. Okay, so this is the use of sort again, and after that, unique. So basically, if you have say for example, in a file you have a lot of repetitive rows or repetitive lines in the file, and you want to just save the basically the unique file elements of that file into another file, or you just want to print uh, the unique elements of file, then basically you want to use this command of unique. So let's write unique, but the point is we do not have redundancies in the file, so let me introduce some redundancies. Let's get a few more ones. Let's get a few more 13s. Let's get another 25, 9 again, 90 again, like this. Okay. So now you have a lot of repeating numbers. Let's write out this. Okay. Unique test file 1.txt. So let me copy this file. See, it's only giving you the unique elements inside the file. So if you see the original file, I have written 1 5 times. So it only takes it 1 times and gives you the output like this. Now it's the same thing if you want to Save this in another file, you do a greater than and save it in another file. You move the output to another file. Okay. Now, so another important thing is basically piping. Piping is something which you use is this straight slash. It's on the. I'll show you. I'll show you on the keyboard. Keyboard quality. Which keyboard? Yeah, this upper slash just below backspace. This slash, this straight slash. This is what is known as a piping symbol. Okay, so what does pipe do? Pipe takes, say for example, you want to run multiple commands as well at once. You want to run a sort, then you want to do a unique, then you want to do something else. You want to do multiple commands at once. So what piping does is it the format is like this. The format is like this, multiple commands. So what it does is it first executes this first command and then gives the output of this first command as an input to the second command. Say for example, let's try this. Say you want to first, so this is your file. uh, this is your file. You have a lot of like redundancy, a lot of repetitions. So first you want to remove the duplicates and then you want to sort them uh, according to their lexicographical order. So how you'll do it? What you'll do is basically first this unique command for getting the unique elements in the file. Do this. Then you use a pipe, this straight slash. Just remember, it's not the slanting slash; it's a straight slash. Straight slash, and then you do write the second command, sort. See. So first, what it does, it removes all the redundancies with using the unique command, and then the output of this command is given as an input to this command, and then it sorts it again, right? So now if you see, I think uh, I think first we sort and then we this, like, let me try the opposite thing. See, so first it sorts it, then it's just the it only prints the unique elements in the file. So uh, it's basically doing what it is. It's taking the output of the first command, giving it as an input to the second command. So that's the importance of the pipe. So pipe you'll use in many different ways. So for example, you want to check the first header of the file, then you want to know the word count of the file. So you do this kind of piping. So basically, if you want to run multiple commands at once, or like one command after another, like in a serial manner, so you do this piping. So the first command will run first, then the output will be given as input to the second command, and then so on. So that's the use of piping. Okay, I think we have covered most of them. Okay, so this is basically one of the important parts that I have not yet covered. So this grep and sed is basically something that we use very oftenly. So grep is used to search a pattern in a file. So if you want to see, so normally when we open files in say Word document or say Excel or anywhere, we do a Control F for finding the whatever we want to find inside the but in Linux that is not possible. Yeah. So in Linux that is not possible. So here the alternative is the grep command. So let's, for example, this file, I want to see if there is 2 inside the file or not, the element 2. So what I'll do is I'll do a grep like this. Then I space the thing that I want to search inside the file, space the name of the file. See, it gives me with highlighted marks. See, so 2 is present in this elements. Right. If I want to do say a 25, right, like this means that there are two 25s inside the file. So grep is basically the Windows equivalent of a control F. Normally we do a control F in different softwares or in a web page or anything to find a particular string or a number inside the whole data set or the file. So the way to do it in Linux is basically grep. Okay. Okay, it's done. Another command is basically sed. This is a stream editor. So what it does is it's basically replaces a particular, so you want to replace a particular uh, element or a word inside your file with another word, you can use sed. So how it works is basically, so this is the command sed operation. This is basically your original what you want to replace and what you want to replace with, which is a replacement, and these are the flags. So for direct replacement, we use the flag G. So it will look like something like this. So just let me check what is inside the file so that I can do a replace here. Okay, so say for example, I want to replace all the ones in my file with say 100. Yeah, I want to replace all the ones in my file with 100. So the command would be like this. So sed -i, which gives you basically it's telling this. And the command is the syntax is like this. So operation will define as replacement, which is given by G, and I want to replace one. So one is this comma this line. Then I want to replace it with 100. So I put 100 here. Sorry, this is S and this is G, and all within inverted commas like this. Okay, this is the command that I want to replace one inside my file with 100, and after that I have to specify the file name as well. Now if I check the file, see, all the ones have been replaced by hundreds because these are all considered as strings. These are not considered as numbers. So not only the single ones, but also 13 and say for example, this was I think 11. So every one has been replaced by 100. So this is very useful for a string you want to uh, if you want to use, and yeah, so for numbers also you can do it like this. So these were all the basic commands that we basically use. Another thing that we'll use is basically a wget command. So I'll just quickly show you how that works. Say for example, uh, I'm not sure if all of you have heard about the Thousand Genome Project or not, but if you haven't, I'll suggest you take a look at it. I'll send the link here. It's a very interesting project. It's not thousand anymore. It has crossed thousand a lot times back. But basically, the idea was to analyze genomes of thousand individuals of various different ethnicities across the world and check for variations and what are the variations present in particular ethnicities compared to other ethnicities and stuff like that. So this is the Thousand Genome Project. Say for example, from the Thousand Genome Project, I want to download some of the vsaf files. Vsaf from the FTP link. Sorry. Yeah. this is the phase 3 release, and this is the FTP side. So what they have done is they've divided each chromosome, divided the whole VCF into different chromosomes, and they have provided it in links like this. And I want to download one of these. So for example, I want to download the chromosome 1 uh, integrated call set for the SNP. So what I do is I click on it, I copy the link address. You can do it's the same for Windows, doesn't matter. And I want to download it directly in my Linux terminal. So I go to the terminal, say this test data directory only I want to download. I go wget. So wget is a command where the command is wget space the link and it will download. So wget space the link of the whole file, and I give enter. Now it will now see it will start downloading. It's a very big file. I'll not allow it to download. Okay, let's allow it. It's not going to take much time. But yeah, so the command is wget space the link of the file. So if you want to download any kind of files from the internet and everything, and if you have a FTP link or any kind of link if you have, you can directly download using wget. You do not need to download in your like manually from your browser and then move it to your particular folder. Wget actually helps you do that like without any hassle. Okay, so it'll take a minute or something more. Let's wait for it. I'll I can and show you how the VC files looks like as well. Okay, so see it has been downloaded and it tells you the average speed and at what time it has been downloaded and everything. This is the total size of the data set. And let me check in my folder. Yes, see this is the file. This is a zip file. .gz is basically a conzip. It's what it's called as. But still, these type of zip files you can see using less. So I do a less. See, now I can scroll through this. See? So this is the VCF file. Don't get overwhelmed. So basically, these are the main columns that we are interested in. So chromosome position, ID, reference, and alternate allele, quality of the particular variant, and info and format, and rest of this HG stuff you see, HG009697. These are all the sample IDs. So there are a lot of sample IDs, and this 1000, what it gives you, say for example, this is the first variant. So this is in chromosome 1. This is the position in, of the variant in chromosome 1. This is the reference allele. This is the alternate allele, meaning A has been replaced with AC. So basically, there's a C insertion in this particular position. Then pass is basically the quality criteria for different kind of collars. So this has been called a dragon or any other kind of collar. So they give if the variant they are giving is a pass or a fail variant according to different criteria. They give it like this. These are allele counts, number of this particular allele found in place of this allele in the whole population. So this is that, and you have another set of like different kind of frequencies. So this is the frequency of this allele in East Asian um, population. This is the frequency of this allele in American population, and every this kind of thing. And the 001110, these stuff are basically the genotypes. If you remember the genotypes can be like it can be homozygous, it's a 00 or a 11, or it can be a heterozygous 10 or 01. So uh, these are the all the genotypes of these samples. These all these 1000 samples for this particular variant. So this is how our VCF files look like. I just giving you an overview of how it looks like, but we'll come to these later when we do some hands-on variant calling and stuff like that in the future. We'll come to those, but I just wanted to show you how we download and how we basically check different data. Now, if you want to say, for example, unzip this file, this is a gzip file at the end gz. There you will also find files with .bz at the end. So those are bgzip files. So the thing is that these are all compression techniques, algorithms, which basically takes a big file and compresses into a smaller file. The algorithms are slightly bit different for each one of them, so the software is a little bit different. So for this one, it's gzip. Gzip needs to be installed in your system to work. Here it is. So I can do a gzip hyphen d is basically telling it to decompress. So if I want to decompress this file, I do a gzip hyphen d. It'll take a little bit of time because it's a very big file, but this is how you do it. Gzip hyphen d space the name of the file. Okay, it's taking a little bit time. It's a big file. See here also while you're downloading as well, it is saying it's a gzip file. So there are other places where also you can check out what kind of compression has the file gone through. According to that, you need to uncompress. If you say, for example, it's a gzip file, you want to just unzip it using a bgzip software, it won't work like that, right? It'll give error or it'll create a corrupted file or something like that. So you need to know what kind of zipping has been done on the file, and then you can do the similar decompressing of the file. So give it a minute, it'll be done. So this VCF file that like showed you, the VCF stands for variant calling format. So this VCF format is mostly used for denoting variants. Variants, as in for this case, it was SNPs, single nucleotide polymorphisms. It can be SVs as well, but the format is kind of standardized across different kind of variants, and we use VCF files to write these variants. So it's a standard data format is followed. So yeah, so maximum SNP data or SV data or any kind of like other than sequence data. So sequence data will be in FASTQ format as we discussed last time. But other than anything on see no space on left on this device. Okay, so it cannot do it because the space requirement is too much. So I'll not go ahead with it. But basically, yeah, this is how you do it. You check if it has been.
I have a query.
Yeah,
So there are some files which are with tar.zz, right?
yeah.
So are they double compressed or
No, so what they do is basically, I'll show you the tar documentation. Uh, in tar, there are multiple files that are compressed within itself, and and the whole folder containing these zip files are also compressed together. So if you want to know the tar command, I think this. Yeah, so these are different types of tar commands inside it. So if it is a .tar file, you need to unzip it using tar only. So if it's a .gz file, you need to unzip it using gzip only. So these are the different types of compressions that are used to compress different types of files. So tar is generally used to compress individual files and also the whole directory altogether. So it's kind of it's not exactly a double compression, but in a certain way actually it is. So but technically it is not double, but you can imagine it to be like that. So for if you want to extract the file, say for example you want to extract a .tar file, you do tar then hyphen x, which is basically and that's the option that gives you to extract the file. V is basically if you do a xv, v will like keep on updating on your screen which part of the file has been uncompressed and which is still compressing xv, and mostly xv. And if you want to like you create a tar file using this compression, you can use a hyphen z. right? So mostly we'll use XV for tar files for uncompressing and Z for creating the tar file using the compression. Uh, Here also there are two options. You can use gzip compression on inside the individual files. You can also use bgzip2 compression. So these are the two different compression techniques that you can use inside the individual files, but the whole file will be created as a tar, right?
But we need to use two different commands, right? For first we need to extract the tar file. I
No, no.
mean, I if
You,
what I remember, that we
yeah.
need to extract first the tar file and then the zip file. I may
you
be wrong.
can you can you can do it together, like say you can do it a
Okay,
tar hyphen xv, something like that. So you can give this command together, like
okay,
xvf, these things you can do it together. You can do it separately as well, but you can do it together. In one step it will unzip and give you all the folder files, right?
okay.
Okay. So tar is actually another type of compression that we see. Thank you for reminding me. I actually skipped this one. But tar is actually one of the type of compression that you'll quite frequently see for different kind of software specifically. They are compressed as tar files, which you need to compress. Okay. Uh, yep. That's all from this side. So also, we'll look into these FastQ files that Sir has given us. So I gave you the Google Drive link. Please use it. Pinning this message. So inside the Drive link, you have these two. These two first two files are basically the FastQ files. I'll download it here. Uh, but after that, I'll move it to my Linux terminal. How I'll move it, I'll show you that also. Just let it download. These are small files. Do not take much time. Yeah. So these two files have been downloaded. So these are in my download folder. Read1 FastQ and read2 FastQ. Now what I want to do is I want to move them. So this is in my personal computer. I want to move them to my Linux system. So one command we use generally is basically scp. So I'll pull up another terminal. So this terminal is in my system. It's not in the connected system. So this terminal is my system. I move to downloads. So these are the FastQ files that are present. Now I want to move this to my connected Linux terminal. So the way to do is scp. scp, then you give the name of the file. So this, let's move it one by one. scp this, then it's cp, mv, scp. All of them have similar kind of syntaxes. So you give the command, then the name of the file, and then space the destination you want to go to. So this is in another system, so I want have to give the whole IP address of the system. 10 point. Let me check the IP address once. Yeah, 10.25.154, and I have to put a colon like this, and this curly thing gives, it's basically the home. I want to say move it to downloads, and what was the folder that we were working in? Sorry, this one. Yeah, downloads, Unix tutorial and test. I want to move it in this test folder now. This first, let me delete that thing because it's taking a lot of space. Yeah, something like this. Now, let me delete this file. RM. Delete for deleting, we use RM, and it's gone. Right? Yeah, it's gone. Now, let's move this FASTQ files to this folder. Let's ask for my password. It has started moving. I just moved this. So this was read one. I'll move the read two as well. It's gone. Both of them have been deposited in that folder. Now let me check if they have already come. So this is the test folder. Let me check. See, the FASTQ files are here. So this SCP is something that you use to transfer files or data sets between different kind of systems. In the same system also you can use SCP to transfer, but it's basically a a modified version of CP, which is a copy command. Yeah. Okay, now let's try the fast QC on this. Go to fast QC. This is the website of fast QC. I hope all of you have seen this. So it has all the details and you can look into the different projects and everything. So this is the download option. I'll do a wget. Okay, so I'll copy the link and I go here and I do a wget. It's downloaded.
Can we use Conda environment to download the tools?
Yeah,
Other
yeah. So for what
yeah.
happens is more. So few tools like these. So for example, FastQC also I think has a Conda environment. So maximum tools or softwares that you use, BAM tools, SAM tools, or BCF tools or BET tools, everything. So they have so in the GitHub, if you go and check out, so they'll have a uh, option to get the software from source, which is basically you clone the GitHub repository and you do a make install on that GitHub repository and you can install that thing. Or what you can do is you can use Conda and through Conda you can install it. But remember one thing, so maximum softwares will be best working while you are running them from the source. So in Conda there will be some limitations because it's Conda is basically a it's a wrapper of the software which is deposited in the Conda library and you're downloading it. So all the functionalities might not work. So I'm not saying it will not work, but it might not work. So keep in mind when you are doing that. So when you are doing that, like check for reviews and everything. How's the Conda environment working for that particular software and not. So in most cases, what will happen is you'll have some limited capabilities for the Conda environment. But in certain other cases, it will work just fine. So it depends on software to software. So of course, I think you'll it's better to have a idea about what are the limitations of those softwares before you um, download the Conda environment, right?
Okay.
Just a second. Just let me open my system once. Okay, sorry. I think I downloaded the wrong file here. This is not the file. Uh, RL. Okay, let's go back to FastQC. Yeah. If you go to download now for Windows or Linux, this is the folder that is you can download. For Mac, this is the one. Download for the Linux one. So I do a copy link address, do a wget. See, FastQ uh, .zip has come. Now, since it's a .zip uh, file, we need to unzip it. And since there is nothing mentioned GZ or BZ2, we can assume it's just a simple zip folder. So we can unzip it using just an unzip command. So unzip. So it has unzipped all the files inside the folder, right? Now let me check. See, your folder has been unzipped. So we move on to FastQC. Now check the things inside the folder. So these are all the what to say elements inside the inside the folder of your FastQ software. This is your command. So let's run the command once. Sorry, um, QC. Yeah. So this is basically your command, which is the FastQ. This thing. This is the command, and along with it, we'll just see how to run the FastQ files. Okay. So here. So let's go here. So this install.txt has all the things that we need. So I will check this file. So this has all the like this is kind of a README file that is provided here. So this is all the things that you require for running. So one, you can run it as a as interactive mode. I do not suggest that. I'll say run it as a normal mode, and then it'll generate an HTML report we can directly see in the browser. So, but you can run it using interactive modes as well. You can run it as part of pipeline as well, like accordingly. And yeah, so let us check the different. So, mm, yeah. So you do so basically this is your executable. This green fastqc return is your executable. So this is how you run the executable, and hyphen help will give you all the options that you can like for input, output, and the other parameters that you can control using this help parameter. So for us, we'll only require the fastqc name of the file. So these are seq file 1, seq file 2. So these are all the file names. And for f, we'll give that this is a fastq file, and we'll provide the output directory as well. So let's do it here. Just let me make an output directory first. mkdir fastqc output like this. And then we move into the fastq folder. Now this is our uh, executable. We give output like this. Output directory will be, so I'm telling it to move back one directory in the test, and then there is I've made the directory like this, first qc output like this. So the output directory is this, and let's give the files as well. So files is also in the previous directory. I'll just move there, and let me check the name of the file so that I can, yeah. So this is the first file. This is the read2 fastq file. This is the read1 fastq file. So I've given the output. I've given the fastq files, and this is the fastqc uh, executable. Let's try it. It gives you like a timeline about like 5%, 10%, 45%, and so on. So for one read it has done. For the second read also it has done. Now let's check the outputs. You do ls. This is the output folder. So see, it generates this zip files which will contain all the like basically the plots and every metrics of the FASTQ files, but also it generates this HTML file. So let's open this HTML file. First, let me download it from. So this is not in my system. If you remember, this is in my connected system. So I need to bring it to my system to see it. So let me do that. SCP. It's the same SCP I use. Then this is my IP address. Now this is the place where it is. So I have to give the whole path. Right. So if I move here, this is the path. This is the path, and sorry, to give the name of the file as well. So this is the name of the file. Now I want to bring it to my downloads directory. So I do just for downloads like this. ask for my password, and now it is downloaded. Let me do for read one as well. Let me download it all together. Yeah, this has also been downloaded. Now let's go to my download folder. See, these two HTML files have been downloaded. Now if I click on this HTML file, it opens up in the browser, gives you the name of the sample, and it gives you everything from FastQC. So per base sequence quality, you see it's a little bit lower in the end, but then it goes very good. So basically, it should not be anything in the red. This is your sequence quality. Then you per base, per tile sequence quality, it's all blue, no issues here. Per sequence quality score, so average quality increases when basically this is your average quality per read, and this is the quality distribution. Like when your sequence length increases, basically your quality increases here as well. So that's not an issue here. The issue is this one. The per base sequence content is very it's not up to the mark. So basically, either uh, like T is very high or G is very high or low. We'll see it in the lower content. So it's not very good. It should be more of a straight line all across. It should be consistent all across, but it's very fluctuated. So this is not a very good plot for per base sequence content. Now, if you move on to GC content, see, theoretical distribution is this, and your actual distribution is also this. This looks quite good. For base n content, there is no n content. So n is basically, if you do not know what the position is there, ATGC, you put a n instead of any of the four. So n is also not there. Sequence length distribution is also very good. It's your maximum of the sequence length is basically around this 125 mark, and it's very consistent. So this is very good actually. You don't normally see this good sequence length distribution. And duplication level also, like when you increase your length, your duplication level goes down, so it's not an issue. Overrepresented sequences, not many, but here you can see there are adapters that are present, this green one, and also in the last plot as well. The adapter content is quite high. So you have this transposes sequence, which is also an adapter content. You have these Illumina 5' and 3' adapters, which also has like adapter content in them. We need to trim those. And so we get an idea from this fast use report, like what kind of quality control we need to do on the data. Right. So this is for read one. You can get it for read two as well. This is the read two data. So in on the top also it gives you in general basic statistics, total sequences, and the average sequence length, which is like 125 base pair, which is okay. And the percent GC content is also 39%, which is not bad. But what happens is if your basically sequence length is very high, which means basically you have done long read sequencing. It can be in this 125 region, which is basically Illumina, and slightly Illumina is around 150, slightly less, but it's okay. So what you can do from here is, if you remember, you can calculate the basically the coverage of the yeah, of the whole genome using the sequence length and your total number of bases. So if you remember, sequence length into total number of bases, but divided by the total length of the genome. So it'll give you the coverage. So you can directly calculate the coverage from here. So going through, it's the similar thing here also. There's a lot of adapter content, so that's why this has been flagged. So a next step to this would be trimming adapters. So Sir has showed you the BB duck workflow. So I'll not implement that right away, because thing is, uh, I tried downloading that. It doesn't work in the system, so I'll just go through it once if you want. It opened it somewhere. Yeah. So this is the BB duck uh, tool. Uh, See, someone was asking how do we like for the tar file, so we have to do it separately. We do not. See, you give all the commands in one way. in one line. So you do not need to do separate unzipping. You give it all at once, it does that for you. Anyway, so yeah, basically this is the portal, and if you, yeah, so this is the guide. If you want to take a look, I'll send you. But we generally do not use BBDuck. It's a slightly older software that has not been like well updated and stuff. So generally we do not use this. So basically it can do a lot of things. So quality trimming, filtering, adapter trimming, contaminant trimming. So basically all kind of QC, if you imagine, GC filtering, entropy filtering, format conversion, histogram generation, and everything. Quality score recalibration as well. So it does a lot of QC, but it's a slightly dated tool. We have better tools right now, but it's one of those that is like that is still around. So it does a lot of stuff. It's I'll not like show you by an example, but if you want to trim the FASTQ files, actually I tried doing that, but for some reason it does not get installed in my system, so I could not do that. So this bbduck.sh file will be inside the zip file that you download for this software. So you go in the software, you give the input as your read file, your output as your some whatever the name you want to give. You want to give the reference adapters. So adapters will have you want to know the basically the sequence of the adapter to remove it. So inside the folder, uh, let me actually download and show you what's inside the folder at least, so that it will be.
So can we use Trimomatic?
Yeah, Trimomatic is something that is good actually to use. You can use Trimomatic. Another thing that I was going to show you is GATK. So GATK has a lot of like a lot of tools for different purposes. So I'll show you some. Just let me give you the link. Sorry. Yeah. GATK is something that you can use. So it has all kind of tools. So you have best practices, workflows. This is something that is like state of the art. We use currently for all kinds of data sets, and this has also tutorials. So this has certain uh, trimming softwares as well. GATK remove adapters. Acha, GTK has this Mark Illumina duplicates, Mark Illumina adapters. Illumina Yeah, so this is a Picard tool that GTK uses. So GTK is a wrapper, so it has all this like hundreds of tools like that. So GTK is a wrapper which has all the tools, and like you could use. Actually, I'll show you once if you like. Trimomatic also you can use. Trimomatic is well known. But why I'm telling about GATK is basically because GATK has all the tools together. How it works, and let me show you. Okay. So I have it in a module in my HPC cluster. Load GATK 4.1. Now if I take GATK, so, mm, just give me a minute. It shows it here only. GTK. So this it's not showing up for some reason. This, yeah. So see how many tools it has. GT has everything. So starts from here. So you can do base calling, like you can check for base calling, so how it, if it is good or bad or anything. You can do like variant discovery with CNVs and other stuff. You can do coverage analysis using different set of tools. You can do quality control and diagnostics. There's a like set of tools here. You can read it. But like we have all these tools together in one place. So something that many in many papers that we'll see is basically they are using GATK because it's very easy to use and it's all in in one place. So as the name suggests, genome analysis toolkit. It's the full form of GATK, and uh, it's developed by Broad Institute, which is a collaboration between MIT and Harvard. And like they actually have this thing is actually very good. So the equivalent of Trimomatic or your basically in this case BV dark would be mark the illumina adapter. So these are different steps. So one step it will mark the illumina adapter, next step it will remove those marked adapters, next step it will recalibrate the base calls. But if you remember, so when a sequencer is getting the output in terms of like ATGC, what it does is it captures the light, and there's a base calling software which converts that signal to your whatever base it seems suitable. So the whole Illumina, the adapter thing for this one Illumina, so the adapter things on both ends of those also has been like called like the bases in those adapters has also been called with a certain amount of confidence and a FID score. So those bases need to be removed, and depending on those bases also, the rest of the bases, the score of those bases will also be recalibrated slightly, because the quality of your base caller also depends on the quality of which it has called earlier. So if you're removing those adapters as well, you need to recalibrate your base qualities across your sequence. So that those are like certain things that you can do with this as well. Trimomatic, you were talking about. Trimomatic is something that also we use. So this is the website for it. You can download it here from uh, if you want. So you can try it out. But if you face any issues in like BB Duck or anything, you let me know. I'll maybe do another tutorial next week for BB Duck or something.
I have a question different from this. What I read about GATK, initially it was developed for human genome,
Yeah,
if I'm not wrong, right?
yeah.
So, can we do, I mean, there are certain modifications have been done in this tool. So, can
Hmm.
we, if we are interested in the viral genome, right?
Okay,
So, can we do viral genome for VCF analysis? So,
okay.
can we do it for viruses,
Yeah,
viral genomes?
yeah. The thing is, the basic stuff does not change much. So the one thing that will change is basically, if you think humans are diploid, so we have two copies of the
Right.
same allele, which does not is not the case for virus or uh, other kind of there are haploid organisms as well. So these microorganisms, they are not diploid in nature. So the issue will come when you're trying to genotype a particular variant or trying to phase a particular variant or something like that. But at the initial stage, this initial QC, so these are initial QC when you're getting the read, you're trimming the read, you're checking for base qualities and this stuff. This is consistent across all organisms. The issues will come later when you are trying to make certain variant calls. So when you're calling the variant, you have to check if it is present in both the chromosomes or not, or if it is present in single chromosome, or which chromosome it is present from. Has it come from the mother or the father, which you need to do phasing for. So those kind of stuff will be different for different kind of organisms, but the initial this QC will be very similar for all the all the organisms, because it's just you are trying to check the quality of your reads, and if your read quality is bad, you're trimming it. It's very intuitive. It's nothing rocket science, and like it's not that difficult thing to do. So like it's not very different across different organisms. So the sequence quality and those stuff will be very same. Depending on this will depend on your sequencer, more on the sequencer, less on the organism. So these stuff
Right.
you can
Actually,
do using
I was asking
GPT.
about the VCF specific only. I mean VCF, so that's like
VCF में there are
it's
issues because,
uh,
as I said, like for variant calling, humans we call it differently because we are deployed and we have certain like things we check. For haploid organisms, the variant calling is slightly bit different. We call variants on both the strands of the chromosome, which is both the basically the coming from the mother and the father as well. When you're doing germline variant calling, if you're doing somatic variant calling, it's kind of similar, but if you're doing germline variant calling, it's quite different for other organisms compared to humans. But like again, humans and cattle and pigs, these will be like done similarly. But if you're doing say for a plant or a haploid plant or some sort of virus or anything, those things you need to keep in mind. The genetic structure is inherently different from humans, so those things you need to keep in mind. And there are several pipelines. So if you want to analyze a viral genome, there will be a pipeline for a viral genome specific to the viral genome only. So you can follow those pipelines. You don't need to follow
oh,
GNU.
okay. Thank you.
Yeah. Okay. Uh, yeah, that's all from the like in terms of the tutorial side. I think I've covered mostly everything. I have not covered the BB duck thing, so please let me know if you face any issues. I'll maybe cover it in 10 minutes later on. I'm leaving my email ID here. If anyone faces any issue in BB duck or anything else, just let me know. I'll cover it in the next class. Uh, I tried, but this was not installing in my system. So sorry, guys. Okay, so we'll quickly go through the MCQs. The MCQs are not very, like what to say, it's not very thought provoking this time because these are all Linux commands and everything. So just we'll go through quickly. And write the answers in the comment box, in the chat box. Okay, this is quite straightforward. It's basically WSL is what it gives you is basically to run Linux in a Windows system. So it's option both B and C. It provides a terminal for Linux, but it can run inside the Windows operating system. So yeah. This is quite straightforward. It's basically SSH, as I showed you, like how to connect to a remote server. So you do SSH space your name, not your name, basically your profile name @ type address. Then it asks for your password if it is protected. If not, it will directly log into your Linux terminal. So yeah. Okay. So RMDIR only removes a folder when it is empty. If it is not empty, it will give you an error saying if the folder is not empty. If you want to remove a folder that is non-empty, you do RM-R. So RM space the file name will remove the file name. If you want to remove a folder which is non-empty, you do RM-R space the name of the folder. It will remove it, as I showed you in the tutorial as well. Okay. Okay, so I have not talked about the manual. So it actually is like the command is space the name of the command. I'll just show you once here. So man space ls. It gives you the whole synopsis of what is ls, what things you can do, what are the extra commands with ls, what everything you need to know about ls. It gives you that. So this was for ls. Let's see for say unique. Everything you get it like this. Okay. So that's the command.
We can answer in the chat box, right?
Yeah, yeah. Uh, I thought nobody's answering. Sorry, I did not check. Sorry, the answer is not written here, but yeah, the correct answer is head of ABC. So if you want to see the first few lines, it's head of the text of the file. If you want to see the last few lines, it's tail of the file. And if you want to open it in an editor, it's VI. Okay, so the correct answer is A. Yep, it's C. I also have not provided the answer here. So yeah, now this is the command. So SSH space username at the rate IP address connects you to the server. And sorry guys, the next answer is I think just give me a minute. I think the PPT has been messed up a little. Just a minute. Yeah, this is the correct answer is C. SSH username space like at the rate IP address. So, I let's see. B. Okay. Yeah. The answer is B. So the command is basically grep space the word or the expression that you're trying to find in the file space the name of the file. It just works as a control F as equivalent to Windows. Let's actually, since nobody has answered this yet, let's actually try all the commands. So first is, so these are all my, just let me tell you, these are all the files that are there, like 4 files here. So the first command is ls-l. ls-l doesn't give you the number of files in the folder, right? It just shows you the file again. wc-l, it won't because it's a word count. Still, I'll run this. wc-l will not give you anything. It's basically
When you give this ls hyphen l, it shows total 2060. What's this number?
this number is basically I think the total file size of the all the files included. So I think this gives in KB or I think MB. I think this is MB. This is around 20 MB. This is around like 260 MB around. So it
Okay.
gives you the total file size. It's not the total number of files inside there. Right. This is the size. So normal ls also you do, it won't give you anything, but if you do ls hyphen l or t actually sorts by time, and if you do an r, it sorts the time in reverse. But since all the time are same, it's not sorting here anything. Let me go out here. So ls hyphen ltr is sorting it backwards, lt is sorting it, it's just the same thing in the opposite direction, and this is the total size. These are all the permissions, and these are the individual sizes. So this is not actually the size of the folder. This specifies the folder, but inside the folder size will be different. So if you check it and do an ls-ltr, it gives you a separate folder size, because this is actually 4096 bytes is required for a folder to create. It's not the size of the folder. For the folder size, you have to go inside and check, but outside it gives you the actually the total, all the total sizes summed up across all the folders in this particular directory. Okay. So yeah, ls hyphen l did not work, wc hyphen l did not work. This one, ls, then you pipe it wc. Oh, sorry, have to give a space. It gives you the number of files. Let's try it on another folder here. ls. Just remember there's a space between here. So if you do not give the space, it will give an error. Right? Okay. Gives you the number of files. So let's check it. Yeah. There's 7 files in this folder. Gives you the number of files here. Okay, so it's what you're doing is you're listing the files and then you're piping it as an input to WC-L. WC-L will like count the number of lines in a file or in a folder or in a directory. It will count the number of lines. So you're giving a list of all your files and you're asking WC-L to count the number of lines. So that's how you'll get the total number of files in the directory. Right? Okay. Answers here. Do you have any answers? No. So the basically the correct answer is option A. So I is basically when you try to edit the file. So you open the file, you press I, and it gives you the insert option. If you remember on the left below, it gives you the insert option. Then you can edit out the file. And when you are like you want to save the edited file, you have to use colon wq, write and quit. So this is just quit, this is write and quit. So if you want to save the edited file, you do colon wq. If you have not edited or anything, you just have seen the file, you just do a colon q, and it does not save the file. So the correct option is option A. It's actually quite straightforward. It's kill space the ID of the process. But this will the thing is this thing is only required when you are running it in some sort of a what to say if you're running in a queue or something, or like there's an ID associated with your process. So you have submitted a job somewhere for a command, and that has been given as an ID to you, that job ID. So then you can use kill space the job ID to kill that process. This is usually more seen in HPC systems where we so if you want to run something, so we need to submit it to a job queue, and that job queue takes it up and runs it in a node in the HPC. Now, if you want to kill that process in the HPC, we have the job ID. We just do a kill space the job ID, it kills the process. So this is something that you'll use if you kind of work in genomics or something. So yeah. Yeah, actually B is correct. Um, like this is how you check. I'll just show you once. Say for example, here I have two txt files. So I do first I go into, oh no, I'm in the folder. Let me just check what are the two txt files. So I do a star dot txt. So it gives me these two are the .txt files. Now if I want to see, also want to see something that starts with say this. So what I'll do is ls this star this, it gives me this. So star is something that it assumes okay, like that can be anything. But if you give star at the beginning, it means it can start with anything but has to end with .txt. If you give star at the end, what means it starts with this thing but it can end with anything. So star you can use either ways. So that you can do. Say for example, I want say anything with file something like this. So ls star this star. Then also I'm getting these two files. So star is used to kind of assume that anything can be there, but whatever you type, that must be there inside in the name of the file. Okay, so yep, that's all. That brings us then to this session. I hope I have given you an idea about Linux and Linux systems and how to at least navigate through and uh, check different things. I hope you enjoyed the tutorial. And if you have any questions, you can ask, or else we'll close the session for today. Okay, since there are no questions, I'll close it here. Thank you for joining. We'll meet again next Tuesday, 5 p.m. If you have any issues, just I have given my email ID in the chat. You can write to me, or if you want any further tutorial or like obviously like bound by the course syllabus. If you want any kind of further clarifications of how to do this, how to do that, you may write to me. I'll maybe like have the tutorial inside the next class or the class after that. Okay. Okay. Thank you. Thank you guys for joining.